So today let's start recursion. Today let's start recursion. So what is recursion? Uh, many many will tell like recursion is simply we are calling a function again and again, right? But let's understand it deeply and what actually is recursion. But before that, we in maths also we have something similar which is called PMI, right? PMI, which is nothing but principle of mathematical induction. So in PMI, what do? Uh, we assume that a formula works for works. We assume that for a certain value k it works, right? And what is the procedure? Like we need to prove for k is equal to k plus 1 and sorry, I to n, then n is equal to k plus 1 and n is equal to 1. And if we can prove both these, right, then we can say it holds true for all the natural numbers. So let's see with an example. Let's take the simplest thing which we know in for one formula, that is sigma of I is equal to 1 to k, right? So we are assuming for this the formula is k into k plus 1 by 2. Okay, and what we have to prove? We have to prove key for n is equal to k plus 1, we have to prove this, and for n is equal to, we have to prove. If we can prove these both, we can say it holds true for all natural numbers. How? Like we can use 1 to prove 2, we can use again this 2 to prove 3, so on till k, and we will using k to prove k plus 1 and again hold n. So if we just prove for 1 and if we just prove for 1 greater than k, which is k plus 1, we can say it's hold true for every natural number. So let's see. So we have assumed that formula, and we have to prove for n is equal to k plus 1. Now sigma I is equal to 1 से लेके k plus 1, what 1 plus 2 plus 3 plus 4 से लेके k plus 1, right? So for this we have already this is the summation from 1 to k, which is nothing but sigma of I is equal to 1 to k, right? And we already know the formula for this that we have assumed, which was k into k plus 1 by 2. So we are gonna use this formula here. Okay, so using that we will get k into sorry it was k into k plus 1 by 2. Now again k plus 1, right? So if we just take the LCM, we'll get just twice k plus 1 by 2, and sorry, if we take the common k plus 1, we'll get k plus 2 by 2, isn't it? And this is LHS, right? And if so, this result we got and we already assumed that one formula I is equal to 1 till k, if we do, that was k into k plus 1 by 2, and if we replace k with k plus 1, then also just replace k with k plus 1. So here k is replaced by k plus 1, then k plus 1 into k is replaced with k plus 1, k plus 1 plus 1 by 2. If we do this, what we get? We'll be getting k plus 1 k plus 2 by 2. ठीक है. How did we get this? We replaced k with k plus 1 in this formula, right? And it is k plus 1 plus k plus 2 by 2. This is the same thing which we got when we expanded this one, right? So we can say LHS is equal to RHS. Now it is proved, right? Now we have to prove for n is equal to 1. Okay. So first going with the expression I is equal to 1 to 1 I. This is nothing but summation of 1 plus we don't have to do anything. We have to hard stop with 1. So this is LHS. And if we keep in the formula was I is equal to 1 to k, that was k into k plus 1 by 2. And here if we replace k with 1, let's see what happens. So we are replacing with 1, then it will give 1 plus 1 by 2, 1 into 2 by 2, 2 by 2 is equal to 1. This is the same, this is same what we got here. LHS is equal to RHS. So what we have done till now, we have proved that it works for n is equal to 1. We have proved n is equal to 1 by putting in the formula, and we have also proved for n is equal to k plus 1. Okay. And we have already assumed for n is equal to k. So we have n is equal to k, n is equal to 1, n is equal to k plus 1. So we can easily say it holds true for every natural number, and that's how we do PMI. Okay. Now this is over. Now let's see recursion. How is this even relatable to recursion? So in recursion also we just assume things, right? We just assume. It's like magic. We just have to have faith. Here also we have faith here for n is equal to k, right? And we have proved n plus k plus 1. So we don't have to do this every time, isn't it? Whenever we use formula for all the sum of all the natural numbers, we just use n into n plus 1 by 2, right? We know it will work for n minus 1 also, n minus 2 also, whatever value will give. So similarly in recursion also, it does work like a magic. We just keep faith, or we can say black box. We don't have to worry about the implementation. We'll just use it. So let's try to do some problems. With that, I can explain what exactly it is. So let's take the first question, which is print decreasing. Okay. And we just have a framework for solving recursion question, which is first establish the first have expectation, right? What is expected? Expectation. Now establish faith that this is going to work for the smaller problem or anything. Okay. Then just need faith with expectation. From this is called high level thinking. This is called high level thinking. And from these high level thinking, now we can get a basic code. You can get a basic code. Here basic code is not equal to base case. This is basic code. Okay. And for base case, we have to think in low level, like drawing stack diagrams and all. Okay. So recursion will work like that. Now for print decreasing, we will have expectation. हमारी expectation क्या है function से कि print decreasing, let's say print decreasing for 5. We have expectation like in decreasing function it has to print, right? So it will print 5 4 3 2 1. Okay, and we will keep faith that PD4 knows how to print 4 3 2 1. We just have to keep faith it knows how to print us, right? So from this, can we solve the bigger problem? So the third step was to establish a relationship between faith and expectation. Okay, we'll build it. How we are gonna build that relationship? So PD5, this can say, okay, I'll just print 5, and you just give me just print all the other 40. So this is called high level thinking, and this is base code. Let's just code using this. Okay, we'll have it here only, and let's code with black. What is the problem? Yes, so public static void main string args. Don't worry about what are these. Scanner sc equal to new int n is equal to sc dot next. Print decreasing, we just pass n. Okay, now public static, we don't have to make object for that, it is not returning anything, and print decreasing, here we are passing print integer n. So later on we'll look at what is the base case. Okay, base condition. Let's first write the basic code. What was it? First it will print it, right? String dot out of println, it is going to print n, and then it will call print dec to 4, which is n minus 1. See, we're gonna do this, and after this is the same thing which we have written here. Print n, call the print n minus 1. This is the base code, base code, but we don't know what is the base case. So for this, just we can have what? Stack diagram. Do we have something? Yes, we have. Okay. We have 5 also, and one more thing, main. So first in main we are gonna call pd5 print decreasing 5. Okay, the main is loaded. Now pd5 is called this, 5 is n, like pd5 pd4 pd3 pd2 pd1 pd0. Okay, so this is 1, this is 2. From the statement number 1, what is that? We are printing n, so we are print n is here 5, so 5 will be printed. Now statement 2 is making a call to print n minus 1, n is 5, n minus 1 is 4, so it will call pd4 first statement print n, which is 4. Second statement, it will make a call to n minus 1, so pd3 will be called. First statement, n will be printed, which is 3 here. Second statement, n minus 1 will be called, which is pd2. First statement, n will be printed, which is 2, and second statement, it will call n minus 1, which is pd1. First statement, which is print n, which is 1, and with second statement, it will call pt0, but we don't want to print 0. ठीक है? According to the question only, we can form the base case. So we don't want to print 0, so we won't print it and we will return here. So how did we have base case? From drawing this low level thinking. This is called low level thinking, to get the base condition, because basic code we can get from high level thinking. So here we return, right? Then it will fall back. This is wiped out. Here it came, both statement ran, so it wipe out from memory and return. It wipe out from memory and returned. It wipe out from memory and return. Both statement return. Both statement is already done. Wipe out. It will fall back to main and program is over, and we already printed these. So now we will write just our base condition, which is if n is equal to 0, then do nothing, just return. Okay, so we have seen this now, and see what was there. We are calling recursion function, and we are we have a statement here, right? So what is happening now in recursion call? We are just like the first statement is put first, and after that recursion is made. So these print statement will work first, after that call. We are going up and just we are executing the first statement, then we are making call, executing first statement, making call. So whenever there is a statement before the recursion, it will execute it first. Okay, so now coming to the second question, which is very similar to that, and that is print increasing. Print increasing. So first of all, we will have a faith in that, expectation. We'll set an expectation. If we have pi5, then it should print me increasing order. Okay, 1 2 3 4 and 5. We will establish a faith that if we have a smaller pi4, then it should give me 1 2 3 and 4. Now we have to form a relationship between faith to expectation, and how we are going to do that is by like pi5 was there, right? pi5, we're gonna say, okay, first you print all this. pi4, you print this. Now we just print this one, so print n or 5. Okay, so this is high level thinking, and यहाँ से we got our basic code. So from this we'll just write our code here. Scanner sc is equal to new scanner okay. Now we have print increasing, and we are gonna call n there. Okay, then we have public static. We are not returning anything, so void print increasing. The parameter we are going to pass is n. Now we will have a base case which we will see after the low level code, low level thinking. Base case, so this is for later point. Now what we have, first we want to print print increasing. All 1 2 3 4 will printed by pd4, which is n minus 1, and after that we are going to print n, print ln n. Okay, now let's see the low level of this. Now we're gonna see low level. For what? Low level we are going to see. Okay, for what? Base case. Okay, then again we have this one, bring it here, let's increase the size, and okay, 5. ठीक है, and here main है यार, main. In main we just called in the main this one pi5, let's say. Then it will call for n is equal to 5, which is pi5. Now first statement will get executed. This is 1, this is 2. First statement will get executed and it will call for n minus 1, which is pi4. Now here it will come and it will check this thing. First statement is calling n minus 1, which is pi3. Then again first statement executed and it will call for pi2. First statement it will call for n minus 1, which is pi1. First statement it will call for n minus 1, which is pi0, but we don't want to print 0, so here we will return. So here the base conditions are same. Okay, when n is equal to 0, just return it. Now returning, first statement was already executed, now second will be executed. So here what we are doing, second statement we are printing n is here 1. So both statement are executed. Now we can wipe out from memory. Now it will return. The first statement is already executed, so now second statement will run and it will print n, which is 2 here. So it will print 2. This is 1. I don't know why I draw 1 and 2 similar. So both statements are executed. Now we can erase this from the memory. Now we are going to execute the second statement here. It's print n, which is 3. Wipe out 2, 4. Wipe out. Second statement, print n. Wipe out. It will go back to main, and we have done our work. Okay, now let's see the another problem, which is print decreasing then increasing. Okay, what's the expectation? Expectation is if we have function pdi for 5, we want to print 5 4 3 2 1 1 2 3 4 5. We have a faith that if 4 3 2 1 1 2 3 4, if it is pdi4, if it can print 4 3 2 1 1 2 3 4, this is easy, like this is a pattern, right? N to 1 1 to 1. So here what we are doing, if this wala part is done by this, we have faith. Okay, so what was the third step? Establishing a relationship between faith to expectation. And how we gonna do that? pdi5 we will write as first it will print 5, then pd4 will show its magic. What's the magic? This is magic. Now on last again it will print 5. Okay, and this is this is high level thinking, and this is our basic code. So let's write our basic code first. Again public static our pyara public static void main string args we are building scanner sc is equal to new scanner system.n. we can have n is equal to sc.next int, and we will pass this n in print dic inc. We're gonna pass n. That's it. The rest the function will do. Okay. Public static. Yeah, this is not giving any return value, so void print inc. The parameter we are passing is only n. So first there should be a base case because it's a recursion. We need a base case to stop the recursion, or else it will recurse till eternity. So the base code we can write from what we had from high level thinking, which was first we have to print n, then make a call then make a call to n minus 1, then again and this was simple. Okay, now for the base case what we are going to do, we are going to see low level for what base case. So let's draw this one. Let's have 5 also. So first तो main रहता है, main will call pdi5. ठीक है, तो 5 में लोड हो जाएगा. What it will be pdi5. This is first statement, this is second, this is third. First statement what is it? Print n. N is 5 here, so we'll print 5. So in second it is making another call to n minus 1. N is 5, so n minus 1 is 4, so it will make call to pdi4. Now here when it comes, the first statement will execute, and from that it will print n, which is 4 here. It will print here. Now coming to second, it will make call to n minus 1, which is 3, so it will be pdi3. First will run, so print 3 2. It will make a call to n minus 1, which is pdi2. First statement it will print, second statement it will call, first statement it will print, second statement it will call. We don't want to print 0, so here we will return. So from here we got, if whenever n is 0, just return. Now after returning 1 and 2 was already executed. Now we will execute 3. 3 is again print n. N here is 1, so we will print 1. So now no statement is there, so it will wipe out from memory and will return 2. N is equal to 2. So here 2 statements are already executed. Now third statement will be executed, which is print n. N is here 2, so 2 will be printed. So wipe out 3, it will print 3, wipe out. It will print, wipe out. Print 5, 5, wipe out, went to main, and we are done with this. We have printed. We have seen dry run of this. Okay, so what else? So we can have one observation from here, very clear observation. What it is? I see. So we already saw in recursion, we just keep a faith, and we just build a relationship with faith to expectation, right? We set expectation, we set faith, establish faith, and we build a relationship from faith to expectation. So these are the total 3 steps to have a high level thinking, and from this we can generate a basic code. So first we saw print decreasing. In this, we have what we had to do. We had to print like example PD5 is there, print decreasing 5. So what it will do, it will print from 5 to 1, 5 4 3 2 1. Now we just will have a faith that PD4 knows how to print 4 3 2 1. Okay, 4 3 2 1. So this is expectation, this is faith. What we are gonna do, we're gonna build the relationship from for faith to expectation. Key PD5 will say, okay, I'll print just 5, you just print 4 3 2 1. Okay, and this was like high level thinking. From high level thinking, we just generated a code, basic code. Now for this one, we wrote code exactly same thing, print 5 we called. And from the for the base case, we draw the low level, and here we saw that it will always print in the first condition, and second it will call. And sorry, so yeah, just first it will print, and then it will make call. Print, make call, print, make call, print, make call, print, make call. So we are saying this is first printing, then, and returning, it is just returning. So the main work is done while it is going up. That's why 4 3 2 1 is printed. In this case, print increasing, we saw we had to print 1 to 5. We have faith that it will print to 4, we just print 5. So we wrote just a basic code, like we are calling then printing, calling then printing. We just saw from the low level diagram base case that whenever the n is equal to 0, we will return it. So 1 2 3 4 5. Now this is done. Print decreasing, it increasing, it is a combination of both the questions. So 5 4 3 2 1 1 2 3 4 5. So it is a worth revision or revision of question. If we do this revision now, we can have both that question, and it is very good. Like we are doing both, like we are making a call, we have one statement above recursion, below recursion. So we what is good here now, the statement which is above the recursion is called while we are going up, while we are going up, while we are going up. Then the first statement is executed, and when we complete the recursion, while we are returning, the statement below the recursion is executed. So that was the very fun part. So now, as this is done, I'll end this here and I'll make it part 2. Hope you understood this. Yep. So okay, bye. And what is left is I discussed these 3. Now in second video I'll discuss all the 4. I could have discussed here, but okay, the video will be longer, so